So I see this and I automatically think, how? NASA researchers just discovered the largest planet in the universe. How? When we don't know how big the universe is. Legitimate question, right? I thought so too. So I'm anxious to see what they talking about in this one, all right? So we're gonna check this video out. If you're new, you know what to do. Hit that subscribe button. Let's go.
The universe is much larger than anything humans could possibly imagine, and it has been a historic decade of fascinating discoveries of new worlds. Just this year, NASA discovered more than 5,000 confirmed exoplanets or extrasolar planets. They range from super-Earths to gas giants like Jupiter, to ice giants like Neptune and other far-off planets. Although planetary scientists have found many of these odd locales, it's believed that our Milky Way galaxy alone has more than 1 trillion exoplanets. We'll now demonstrate how researchers just found a planet that is so enormous that it easily dwarfs the size of our closest neighbour. What is this massive superplanet? And what exactly do we know about it? Let's find out. The planet known as B-Centauri ABB, or B-Centauri b, after its discovery, challenged the knowledge of astronomers and scientists alike. This large planet lies in an environment that was previously thought to be too hostile for a planet to develop around a massive pair of extremely hot stars. According to the European Southern Observatory, which captured images of the planet from its very large telescope in the Chilean desert, no planets have previously been discovered around a star that was more than 3 times as big as the Sun until B-Centauri b. As one of the most massive planets ever found, the B-Centauri b is an exoplanet that exists outside of our solar system and is 10 times as massive as Jupiter. Mark Jansen, an astronomy professor at Stockholm University and the study's principal investigator, stated that it completely changes the picture about massive stars as planets' hosts. The highly large and hot B-type twin star in the Centaurus constellation is at the core of a solar system. It produces a significant amount of high-energy ultraviolet and X-ray radiation, which strongly impacts the surrounding atmosphere and should operate against planet formation.
Which should continue to pique our interest, because in the other video where we talked about Type 7 civilizations, what were we needing? Energy. So I understand why NASA and astrologists and different ones, astronomers, are looking at some of these different things, these stars and stuff, and seeing how the energy is transformed to possibly do what? Exactly.
Was once thought that it would be incredibly difficult for big planets to develop around B-type stars, since they are thought to be quite corrosive and harmful. Everything is on a massive scale. The stars are bigger, the planet is bigger, and even the distances are bigger in this harsh environment, which is governed by intense radiation. According to research, the findings demonstrate that planets can exist in star systems that are far more massive than would be predicted from extrapolating from earlier findings. It has one of the broadest orbits ever found, measuring 100 times farther than the separation between Jupiter and the Sun. The planet's survival likely depends on its great distance from the pair of core stars. Jason predicted that there would be a general rise in the amount of time spent searching for planets around high-mass stars, both for the sake of finding them and of defining them in order to determine more precisely how they may have formed. While we wait for that, let's look at another massive planet that is 9 times the size of Jupiter and forming in a violent way. In general, cooking a meal can be compared to how planets form in our universe. Both the ingredients and the cooking procedure used to create a planet are subject to change. A planet was observed by scientists using the Hubble Space Telescope as it underwent disk instability, a violent and dramatic event that has been compared to a flash fry. In this approach, the protoplanetary disk orbiting a star cools and is broken up into one or more planet mass fragments by gravity, rather than developing into a planet over time from a small core that gathers matter and gas. Hubble's resolution and lifespan proved to be a crucial missing piece in the puzzle, as astronomers have sought definitive proof of this process as a likely candidate in the formation of giant Jupiter-like planets. The young star, thought to be only 2 million years old, is surrounded by a protoplanetary disk of dust and gas with a distinct spiral structure swirling around it. This is the location of the newly formed planet. That roughly corresponds.
What does that look like to y'all? Does that not look like an eye staring back at y'all? Okay.
To the time during planet formation in our solar system. At this time, the solar system is 4.6 billion years old. The study's principal author, Thane Curry of the Subaru Telescope and Eureka Scientific, said, "Nature is clever. It can produce planets in a range of different ways." The raw materials for every planet came from a circumstellar disk. The predominant idea for the formation of Jupiter's planet is known as core accretion, a bottom-up method in which planets trapped in the disk develop from tiny debris that circles a star, and then collide and cling together to produce larger objects. Gas from the disk is then gradually accumulated into this core. The disk instability approach, in contrast, is a top-down model in which gravity causes a huge disk surrounding a star to quickly shatter into one or more planet mass fragments as the disk cools. The newly formed planet, known as AB Aurigae b, orbits its host star at an incredible distance of 8.6 billion miles, which is more than 2 times farther than Pluto is from the Sun. It is most likely about 9 times more massive than Jupiter. If ever, it would take a very long time for the planet the size of Jupiter to develop at that distance. This leads scientists to the conclusion that this planet could not have formed at such a great distance without the disk instability. It also stands in stark contrast to what the generally recognized core accretion hypothesis predicts for planet formation. The near-infrared camera and multi-object spectrograph and space telescope imaging spectrograph data are combined in the new analysis. This data was compared to those obtained by the cutting-edge SCO-X-AO planet imaging instrument on Japan's 8.2-meter Subaru telescope, which is perched atop Mauna Kea in Hawaii. Given how difficult it is to distinguish complicated disk features unrelated to planets from complex disk features related to young planets, the amount of data from space and ground-based telescopes proved crucial. It is very difficult to interpret this system, according to Curry. This is just one of the reasons Hubble was necessary for the project. A clear image made it easier to distinguish between the light coming from the disk and any planets. The huge disk of dust and gas swirling around the star AB Aurigae is angled nearly face-on to our perspective from Earth, which was made possible by nature itself. Curry underlined that Hubble's endurance was vital in assisting scientists in determining the protoplanet's orbit. At first, he had serious doubts that AB Aurigae b was a planet. The Hubble archived data and the imagery from Subaru were crucial in causing him to change his view. According to Curry, we could not detect this motion for about a year or 2, but Hubble provided a time baseline combined with Subaru data of 13 years, which was sufficient to be able to detect orbital motion. Olivier Guillon of the University of Arizona in Tucson and Subaru Telescope in Hawaii claims that this result makes use of both ground and space-based observations and allows for the use of Hubble archive data to travel in time. Now that AB Aurigae b has been examined at several wavelengths, a dependable picture has developed. This new finding provides compelling evidence that some gas giant planets can originate via disk instability mechanisms. Gravity is ultimately all that matters, since one way or another, the byproducts of star creation will be drawn together by gravity to create planets. Astronomers can better understand the evolution of our own solar system by comprehending the early stages of the development of Jupiter-like planets. Future investigations into the chemistry of protoplanetary disks like AB Aurigae will be made possible by this discovery, particularly those using NASA's James Webb Space Telescope. On the other hand, the Transiting Exoplanet Satellite Survey, TESS or TESS, a NASA mission, has discovered a bustling neighborhood just 33 light-years from Earth. It has a star in the center, a few planets orbiting that star, and at least 2 terrestrial Earth-sized worlds, according to the scientists that made the discovery of this alternate reality. It would take you roughly 330 years to reach this solar system-like region of the galaxy if you could move at 1/10 of the speed of light. That is
We're not gonna go down that rabbit hole. We went down that rabbit hole last night, speed of light, all right? But at the same time, man, this is what angers me when I see people complain and I get some of the gripes about, the funding that's going towards NASA and different things like that, when we still have things here on our planet that we still need help with and to fund and understand and research and different things here and take care of and support. I get that, you know what I mean? But bro, the money that's going towards these telescopes and the discoveries that are being made is also assisting things on this planet as well. And I think that's the barrier in between where people just aren't understanding. And like I said before, I was once there because lack of information. If you knew better, you do better. So knowing what we're up there doing and the information that the Hubble or the Voyagers or the James Webb is currently doing, then you would probably change your tune, bro. Because it's not only discovering things in space, it's also telling us things about our planet, of where we could be headed in the future or what could be possibly coming up, or, you know what I'm saying, protecting us from different things. So that's just one thing I heard recently that still kind of angers me.
Galaxy, if you could move at 1/10 of the speed of light. That is obviously not feasible for a number of reasons. However, we can draw a very accurate picture of this neighborhood by utilizing specialized Earthborne tools like telescopes and spaceborne spectrometers, possibly even the James Webb Space Telescope, once it's fully operational. The host star of the system, designated HD 260655, is a relatively tiny cold M dwarf, according to what we now know. M dwarfs are 10 times more prevalent in the cosmos than our Sun, a G-type main sequence star, although being 10 times less massive. The inner planet, which is about 1.2 times larger and twice as massive as Earth, revolves around its star every 2.8 Earth days. The other alien world, which is 1.5 times larger and 3 times more massive than Earth, orbits at a distance of 5.7 Earth days. Both are regarded as rocky. Given the brightness of their stars, both of the planets in this system are among the greatest candidates for atmosphere research, according to Michelle Kunimoto of MIT's Kavli Institute for Astrophysics and Space Research, one of the discovery's main scientists. This comprises investigations that seek to respond to issues like, is there a volatile rich atmosphere around these planets? And are there signs of water or carbon-based species? In other words, a protective layer similar to the ozone layer on Earth and living things similar to humans. According to Kunimoto, these planets are fantastic testbeds for those explorations. Okay, but before you get...
And we also got to remember as well to pay attention to the core, not just what's the atmospheric as well, because that's very important, but the core as well. Finding out that we had bacteria at our core was a huge discovery.
Get too excited. Scientists underlined that the recently discovered rocky worlds of interest are probably not livable because they are likely too hot to support water and are located extremely close to their host star. According to the study, the core planets heat up to an estimated 818 degrees Fahrenheit. In comparison, the outer world maintains a comfortable 548 degrees Fahrenheit. Don't you consider that range out?
And I mean at our core, but you know what I mean? Digging down underground, going down super far, we started finding layers of bacteria is what I meant.
Inside the habitable zone? However, if you think you can cope with that extreme temperature, we won't stop you. Nevertheless, the search for habitable exoplanets could benefit greatly from learning more about these worlds. In other words, they might guide future research into the possibility of discovering planets in the habitable zone. Since its launch in 2018, NASA's TESS has been slowly finding exoplanets throughout the universe and has already compiled an incredible catalogue of these distant planets. It basically operates by looking for recurring dips in the luminosity of stars throughout the universe, as these fluctuations in light could indicate the passage of a planet in front of those stars. Consider looking at a lamp while someone passes by it to block your view. Even while you might not be able to determine who specifically blocked your view if you were very far away from the lamp, you might assume that someone did so because the light clearly went out for a little period. That is somewhat how it is with TESS. So while keeping an eye on the satellite's incoming data, Kunimoto discovered one of these dips. They were travelling from HD 260655, the star. The researchers came to the conclusion that there are indeed 2 planets orbiting the star in question, after conducting a number of additional tests, one of which is the well-known gravitational wobble test, which examines whether the light dips are accompanied by some gravitational pull on the star itself. There are numerous multi-planet systems with 5 or 6 planets, particularly in the vicinity of tiny stars like this one. Hopefully we'll discover more, and if we do discover others, perhaps one of them would be in the zone where humans can live. Optimistic thinking, right? TOI 849b, an oddball among wild things. On the scale of our galaxy, a totally weird planet circles a sun-like star some 730 light years away. The planet is unlike anything astronomers have ever seen, either in our own solar system or from afar. It is large, dense, and tightly bound to its home star. With up to 40 Earths worth of material squeezed inside, the roasting world of TOI 849b is the largest rocky planet yet seen. Strangely, despite having essentially little atmosphere, TOI 849b's enormous weight suggests that it should be a massive gaseous globe like Jupiter. It is difficult to explain how such a world came into existence given what is known about how planets grow. A planet as large and dense as TOI 849b is extremely difficult to create without turning into a gas giant. Something went wrong during that routine procedure. Instead, according to experts, the planet is the exposed airless core of a giant planet that should have outgrown Jupiter. Planet searchers have discovered thousands of distant planets within the star fields of the galaxy over the past 10 years. The majority are undoubtedly extraterrestrial, falling into categories like super-Earths, rocky planets larger than ours but less than Neptune, or hot Jupiters, large gaseous planets in close orbits. But TOI 849b defies categorization. This world was also discovered by NASA's Transiting Exoplanet Survey satellite, TESS, which is scouring 200,000 of the nearest, brightest stars for extraterrestrial life. A sliver of starlight was briefly obscured by the planet as it crossed the face of its star, revealing its presence. These ephemeral, gloomy transits showed that an alien world revolves around its star every 18 hours, which means that its surface is swelteringly hot at 2,800 degrees Fahrenheit. Additionally, test measurements revealed that the planet is 3.4 times as broad as Earth or 85% as wide as Neptune, making it an unusually large planet for one that is so close to its star. With the HARPS instrument at the La Silla Observatory in Chile, additional studies of the host star's gravitational wobble revealed that while TOI 849b is roughly as wide as Neptune, it is at least twice as massive. TOI 849b is very dense given its size. The rocky planet may have a thin layer of atmosphere that is likely made of hydrogen and helium, but it does not contain nearly as much gas as a planet that size should. Because of its peculiar characteristics, it is likely the core of a gas giant planet, which should have become more massive than Jupiter. According to current theories of planet formation, planets develop from tiny seeds of rock and ice sown in the whirling disks of gas and dust that round young stars. While some planets like Earth accumulate a tiny amount of material and remain small, others, like Jupiter and Saturn, gather gas and expand into inflated worlds with enormous atmospheres. When a planet reaches a mass of around 10 Earth masses, a process known as runaway gas accretion starts, and the planet's gravity quickly pulls in nearby hydrogen and helium. It stands to reason that a seed with 40 Earth masses should have accumulated an incredible amount of gas. Yet TOI 849b does not currently appear to have done so. We already know that planets like TOI 849b are uncommon, but that doesn't mean they don't exist. We just need to figure out how and why. Thanks for watching another episode of Voyager. While you're still here, make sure to
listen, man. If that type of stuff, like if that doesn't make the hairs on the on your arm stand up, bro, check your pulse. That's all I'm saying is check your pulse, man. Shout outs to NASA and all the great research and information they continuously obtain and put out to us, bro. For some of us, I just wasn't looking. Can't speak for everybody, for me, but now that I'm awakened, I'm woke to it, I'm here for it. You know what I mean? So y'all get at me in the comment section, man. Let me know what you thought of this video, man. And yeah, about to go and enjoy the birthday festivities. So I'll see y'all later, man. Till the next one, I'm gone. Peace.